Hello friends, good morning. This is Abhishek Kumar. In the last class we were discussing about the moment distribution method and the symmetrical approach. Dear friends, approach is very important, the symmetrical approach, because using this symmetrical approach you can solve the questions in within minutes also. Sometimes you can solve the question within minutes also, and in using without symmetry, if you solve the question, it will take 2 to 3 pages, but here it will take only half page, or sometimes it will take 3 to 4 lines. So please adopt this approach. If you have got any problem in this, you can call me. My number is 8909449192. I have also written in this, so you can call me if you have got any problem. Whatever method I have adopted here, please follow that method and get the feel of civil engineering. So let us get the feel of civil engineering and the structural engineering with Abhishek Kumar. Let's continue. For example, this is the question. This question was asked in engineering services. So I am taking some important questions. Please solve all the questions, right? Any question be asked anywhere, so please solve all the questions to get the feel of structural engineering. Usually people, please remember, actually this subject is not clear to the people, and they are teaching the structural engineering from last 10 to 15 years, but still they have not in position what they are teaching. They do not know what they are teaching, but they know I am teaching something and that is right. Okay, answer will be correct, but they do not have feel. So dear friends, to get the feel, if you want to get the real feel, you can contact me, or you can get the feel from video itself. So let's see the question. Analysis of closed box frame. The question was asked in engineering services. See, there is symmetry in the frame. If we see, there is the vertical symmetry, since frame is symmetrical, and this symmetry is beam symmetry. This symmetry is beam symmetry. So we will analyze only half of the structure, and thereafter we will use the modified stiffness factor, that is 2EI by L in spite of 4EI by L. First of all, our aim is to calculate the fixed end moment, means assuming this end is AD, so this is AD, so this will be D, this is A, this is A, this is B, this is D, this is C. This will bend, it will bend like this, so bending end moments will be like this, it will end like this, end moment will be like this, it will bend like this, end moment will be like this. Similar in the fourth portion. Now calculate the distribution factor. Now since we have to calculate end moments only MAB, MAD, MAB and MAD, MDA and MDC only. Rest of will be by calculated by symmetry. So see, this is end A. From end A there are two joints, AB, this is AB and this is AD. I have written this is AB and this is AD. I have written AB star. AB star means stiffness will be taken as 2EI by L in spite of 4EI by L. So this is A to B, this will be 2EI by L. EI is 1.5 EI, 2EI by L, this is 3 by 4 EI. A to D, all ends are fixed, rest of the stiffness will be taken as 4EI by L. A to D will be 4EI by L. Now D to A, again 4EI by L, and D to C star means 2EI by L. These are the stiffness factors. Now we have calculated these moments. One is MAD is clock means plus 2.22, MDA is anti-clock means minus 4.44, MDC is clock means 6.67, MCD is anti-clock means minus 6.67, MAB is anti-clock means minus 10, MBA is clock means plus 10, but these all M are incorrect M, hence we call it M bar, means fixed, and this is the incorrect fixed end moment. We want to calculate the actual end moments. So let us distribute the moment. See, this is D, One is D to C, D to A to B, A to D. So this is D to C, D to A to D, A to B. So we write this D to C, D to A to D and A to B. We write all the values of moment and distribution factor. See, we need not to write these values. We will calculate only these values, right? And by symmetry rest of the values will be calculated at this joint. See, summation of these, for example, this value is 6 minus 4. Let us suppose we write actual value. So this will be 6.67 minus 4.44. This is the unbalanced moment of 2.23. Its minus will be applied, minus 2.23, and it's 0.36 here and 0.64 here. Similarly here, this is minus 10 and plus 2.22. This is minus 10 plus 2.22. So this is minus 7.78. We will apply plus 7.78 and it's 0.64 here and 0.36 here. But dear friends, due to these two simultaneous joints, and its half will be transfer here, its half. Also, its half will be transfer here, half will be transfer. We need not to calculate those values, because using these values only we will calculate those values also. But here there is some problem, that again there is this joint become unbalanced due to this carryover, and due to this carryover this has become unbalanced. So again we will calculate the value. So we will balance it by this becomes insignificant, and finally we add. So we will add. So this value will be D to C. D to C will be minus. D to C is plus. Plus means clock. So this is D, this is C, right? This is D, and this was D. A. This was A. This was A, B, and this is C, right? So this is D to C is plus. Plus means clock, and D to A is minus. Minus means anti-clock, and this is A to D. A to D is plus. A to D is plus means clock, and A to B is minus means anti-clock. Means rest of value will be this anti, this is clock, this is clock, this is anti, this is clock, this is clock, this is anti-clock, this is anti, so this is clock, and this is clock, this is anti-clock, right? Now we can plot BMD. See, let us take outer face as reference face. This is outer face is loaded face, and loaded face as reference face. So we can plot BMD. These two arrow hitting inside means taken as negative and plotted as outside. All the arrows are hitting inside means are negative and plotted outside. Now we can say one loading was here, so this is PL by 4. This will be PL by 4, and again it may be PL by 4 or PAB by L square, and this may be, and this is WL square. Thus we can plot the BMD. Okay friends, our next aim is sway analysis. Sway means so far whatever frame we have discussed, there was no sway, means either frame was symmetrical or loading was only vertical or frame was restrained, right? But if frame is not restrained, see, if frame is restrained there is no possibility of sway. But if frame is not restrained, there may be possibility of sway or not. If frame is non-restrained but it is symmetrical, it will not sway. For example, this was the frame which we have discussed just now. This was the question. This was symmetrical, so no possibility of sway. But if frame is not restrained, then loading is not symmetrical, there may be chance of sway. How will we calculate? For example, this is everything is symmetrical but loading is horizontal, right? It will sway rightward. For example, everything is symmetrical but loading is not symmetrical, it will also sway. One question come in the exam, direction of sway. So some thumb rules are there to calculate direction of sway. First one, number one. First is, let me focus it. Okay, it is focused now. So case 1, number 1, if everything is symmetrical, frame will not sway. Second, if loading is symmetrical but end conditions are not symmetrical, frame will sway. Frame will sway. Whether loading is symmetrical, everything is symmetrical but end conditions are not symmetrical. This is fixed end, this is hinge end. So you will say that it will sway in the direction of weaker column. Weaker column, we will say, means generally people see it by stiffness, that its stiffness is 4 EI. It is more stiff, it is far end is fixed, so stiffness is 4 EI by L. It is far end is hinge, stiffness is 3 EI by L, so it is more stiff, so it will sway rightward. But one more method is, accurate method is that Euler's crippling load. You must have studied PCR. Euler's crippling load is pi square EI divided by L effective square. For this case, if both end are fixed, L effective is L upon 2, but if one end is hinge and other end is fixed, it will be treated as fixed end. So you will say L effective equal to L upon root 2. So Euler's crippling load to buckle the column for both and fixed is equal to pi square EI divided by L upon 2 square, means 4 pi square EI divided by L square. But Euler's buckling load required for one end is hinged is equal to pi square EI upon L upon root 2 square, means 2 pi square EI divided by L square, right? So by this we will say that this is in order to buckle this column we require more load, so it will not buckle, means the direction of sway will be in this direction, means weaker column. This will be the weaker column, right? Pi square 2 EI divided by L, means as load will increase, it will buckle first, so it will sway will like this. Okay. Now case 2, if everything is symmetrical but loading is not symmetrical, then how will we check the direction of sway? So we will cut this frame from mid and from center line, and will see this due to this loading it will go leftward, so it will have also to go leftward, so it will sway in this direction. It will sway in this direction, right? Because how I can say this load, transfer this load here, so you will say okay, transfer this load here, and there will be moment like this, and due to this moment this cantilever beam will sway in this direction, so this frame will sway in this direction. For example, this is the question. This is the question. Cut it from center line. You will see that due to this loading and due to this loading, this is UDL, so it will be point load, so due to this it will move like this, and this is point load, and if I transfer here, if this is the UDL and I transfer UDL here, so it will become a moment and this load. Due to this moment cantilever goes in this direction. If I transfer UDL here, you will see that it will be this type of UDL and this type of load. Due to this moment cantilever goes like this, so this will sway in this direction, right? For example, same is this it is at center line P, so you will say that just cut it at half, so half load will be this and half will be here due to this and due to this, right? So this will be the direction of sway. One or two more cases also there. For example, let us take this. This is the load symmetry, and okay, these are the general cases, right? No more case can be there except these cases. For example, if this is like this is I, this is I, length L, length 2L. So using this formula we can say that this is PCR will be 4 pi square EI divided by L square, and here PCR will be 4 pi square EI divided by 2L square, means it will be 1/4, means it is it require lesser load, means it will buckle in this direction, it will buckle in this direction, right? It will reason behind is that means it will also buckle. When it will buckle, it will also buckle, but you will see that as load is increasing, it will buckle first. So due to this buckling, structure will start to fall in this direction, and now it has also to go in this direction, but this fall is due to this column. This is longer column, its stiffness is less, right? So we can see, we can check the direction of sway. Now next topic is sway analysis. How we do sway analysis. Questions are generally like this. In the university exams, the questions are rare in sway analysis, but in the engineering services or IAS or GATE, in GATE not objective question, in GATE only objective questions are asked and no possibility of sway analysis, but yes, shear equation or the direction of sway like that. But for competitive exam we should study sway. See how we analyze this way. For example, this is the structure, this is the structure, and this is the loading, this was loading. What we will do while calculating while analyzing the this structure using MDM, so this analysis is done using principle of superposition, means we will do the calculation in two parts. First will be the non-sway analysis, and second will be the sway analysis. First of all, I will due to this loading, it may deflect in this direction, right? It will sway in rightward. So what I will do, one person will come here and will push it in this direction, right? And we will he will say that analyze the frame, means now this frame can be analyzed using as usual condition, means this is non-sway case. This is non-sway case, means first of all our first step will be non-sway analysis, means I can apply a internal a hinge support here or some support here which will prevent the sway in this direction, or if had the sway was in this direction, the reaction will be in this direction, but if sway was in this direction, reaction will be in this direction. So by loading we can say that sway will be in rightward, so reaction will be in leftward. So what will I do? I will analyze the structure. I will analyze the structure using this condition, means I will calculate these distribution factors and distribute the moments and calculate the final end moments, right? Now I will using final end moments, I can calculate these support reaction. This is A, this is B. For example, let support reaction, this is HA, this load is P, and this is HB. Now I will calculate this reaction using equilibrium condition. Summation Fx equal to 0, means P equal to R plus HA plus HB, and since I have already P is given and I have already calculated the end moments, so HA and HB are known, so we can calculate R. How? Since we have already calculated end moments, this is MAB, this is MBA, right? Now I will cut this here, so I will show three reaction. As soon as I will cut, one will be shear force, other will be axial force, third will be bending moment. Here also one will be upward, second will be this HA, and third will be this. Now this is point B. I will take moment at B, MB, and will calculate HA. I can calculate HA. Similarly, in this portion, three reaction, this will be HB, and let us suppose this is this moment and this is moment. Let us suppose these are two reaction, this is C. Now also I will calculate summation MC0 and I will calculate HB. Now using this HA/HB, I will calculate R. Let us suppose R equal to P by 2, means reaction is in this direction, means sway force is in this direction. This is called this is sway force S equal to P by 2. Right, this is the actual sway force, this force is the actual sway force. So we have calculated known sway moments, and using these known sway moment I have calculated the sway force, right? Due to this force, structure was going in this direction, right? Then only I will have to apply this much reaction. Okay, so now I will do the sway analysis. How will I do? I will remove this all loading. And assume a structure like this, and I will apply some sway force, any arbitrary, not this S equal to P by 2. I will push the structure in rightward direction, and I will see that the structure will be like somewhat like this, maybe like this, right? So structure will be like this. Now I will calculate, let this deflection is delta, using now I will calculate how much force is required to produce this delta. How I can calculate the sway moments, since these are the ends also. How can I calculate? We have only one method. What is that method? First of all, we calculate fixed end moment, and thereafter using distribution factor we can distribute the moment and balance the moment. So we will calculate fixed end moment. So we will make the sway, means our sway analysis will be like this. We will assume all the ends as fixed end. So our structure will like this end is fixed end, right? And these two ends are fixed end. So earlier this was here, now it will go here, right? Earlier this was here, now this will go here. So due to this delta and due to this delta, I will calculate sway moments. I will calculate the end moments. What end moment? This is clock, so these will be anti-clock. This is anti-clock, this anti-clock. Value will be 6 EI delta divided by L square, 6 EI delta divided by L square. This is also clock, 6 EI delta divided by L square, 6 EI delta divided by L square, right? L may be different, so these values may be different, right? Now, but in this horizontal member, we assume both end fixed, no loading is there, and the beam has gone from here to here, means no relative displacement of the joints, and end moment will be 0 due to sway. End moment in horizontal member will always be 0, only in vertical members will be sway. If sway is horizontal and if it is vertical, it will reverse case, right? So now I will calculate, these are fixed end moment which are false, because actually we have assumed this end as fixed, but this is not fixed. So we will distribute the moment, we will calculate the ratio. For example, this is M bar AB is to M bar BA is to M bar CD, AB BA, BC is to M bar CB is to M bar CD is to M bar DC will be equal to, this is anti-clock, all are anti-clock, so all are minus and values are same. So I can write -1 is to -1, 0, 0, -1, -1. Now these are the ratio. These ratio may be -1, -1, 2, -2, -2, like that, right? So now I will assume any arbitrary value of moment. Let us suppose 10. I will take -10, -10, 0, 0, -10 and -10. Now these are the random moments which I have assumed. Using these moments I will distribute these and calculate the final moments, which will also be the incorrect, because one person would take -20 in spite of -10, so their answer will be different. Now I will distribute in these moments and calculate the final sway moments, which will also be the incorrect moment, and answer, let us suppose answer will be -7, -7, 0, 0, -7, -7. These are the final after distribution. Now what will I do? I will calculate the sway force required to generate these moments, right? So what I will do, I will again write the equilibrium like this, because I have calculated these end moments, right? I will calculate again HA, HB and again S dash. So I will write like this. Let us suppose this is HA, I can calculate. This is HB, HD I can calculate, right? And using this, let us suppose this is sway force S dash. Now I can calculate this S dash as HA plus HD. Now I will say that these are the known sway moments but incorrect. So the correct sway moments will be calculated. See, when sway force was S, when sway force is S dash, moments are these. When sway force is unit, moments are this upon S dash. When actual sway force is S, so final end moments will be S upon S dash into this. So in this answer we have to multiply S upon S dash. This is called as correction factor. Now the final end moments will be known sway moment plus corrected sway moment. This will be the complete process. Let us see by example. See, I take example, a good question. However, since sway analysis is typical analysis, so questions which are asked generally the simple question. I am taking the general question, most general question and most typical question, right? So let us see. This is the frame. Analyze the frame, right? So since loading is unsymmetrical, by looking the frame we can say that it will sway, and a general idea we can say that since load is horizontal, however by looking these member, this is longer member, had this horizontal force not been there, a sway may be like in leftward direction, but due to this sway may be in rightward direction. If our assumption is correct, delta will be positive, otherwise delta will be negative, right? Okay. So first aim is known sway analysis. Known sway analysis means you assume that put your finger here or apply a hinge reaction, apply some reaction here to support this frame, and analyze the frame generally, in general as you do. So how you do the analysis? You do first of all this is assume fixed end, this is fixed, right? Calculate fixed end moment. These are the fixed end moment. Now since this is hinge end, so correction is required, so we will do correction. Look, these are the correction required. Since this is A, this is B, B, C, C, D, right? A to B. A end is hinge, so the earlier moment was 34.6, so apply just opposite. Applied this opposite of 34.6, it will become 0, but half will transferred here, so final will be like this. No need of correction. Final whatever we value and here these are 0. So fixed end moments are MAB is 0, M bar AB, M bar BC is clock means plus, BA is clock means plus, M bar BC is anti-clock means minus, this is clock means plus, these two are 0. Now we will calculate distribution factor. There are two joints B and C, so we will calculate BA, BC, CB and CD. So distribution factors are like this. Now we will calculate end moments. Look how, right? This is called as non-sway analysis, right? So write down the values, distribution factor and distribute. So final values are these are non-sway moment. So one answer is this, and in this answer we have to add sway moment and corrected sway moment. Now using these sway moments, these non-sway moment, we can calculate sway force. For example, at end A bending moment is 0, so no bending moment applied, only horizontal force and there will be some vertical force, right? Now at end B, this is plus means clockwise, there will be horizontal reaction, there may be vertical reaction. Now I want to calculate this HA you can take in this direction or this direction, it is your choice, right? So take MB equal to 0, summation MB equal to 0 means this 0 as moment of this force 0, this force 0, this force 0, right? So only MB means HA is rotating in this direction, so HA into 7 HA into this will be 4 point, this is 4.5 into 3, so it will be 7.5 HA into 4.5 into 3 will be 7.5, right? And 76.7 also in this direction and equal to 48.3 into this direction, so HA will be 9.003. Now similarly C to D, this is C to D, this is MCD is minus means anti-clock, so this is anti-clock, right? This is 5 meter, no load is there, right? One reaction will be like this and one will be like this. Again bending moment about C equal to 0, summation of moment, equilibrium of this lag, summation of moment at C equal to 0, you can say HD into 5 equal to this HD into 5, so it will be HD and it is HA. Now I can say that I have analyzed the frame like this. This is 48, this is 96, so HA, this is HA 9 and this is 5.288. You had applied here, right? So you will say let R is in this direction, so we will write the equilibrium. What will be the equilibrium? Summation Fx equal to 0, it will be 48 and equal to R plus 5.288 plus 9, so R will be 48 minus this, so this will be the reaction, R will be this is the R and its value will be 33.769, this is R, okay? So this is reaction means this much is the sway force in the opposite direction, you see this, right? This is 9, this is 48, so this is R. Means if we would have not applied this R, means frame would go in this direction. So what was the force in this direction? Whatever is the value of R, same would have been this force S. So you say sway force is S equal to 33.769 in this direction. So this is the actual sway force. Now actually it is not so difficult if you understand. it is not so difficult. Now you will do sway analysis, right? Sway analysis, how we will do, we will assume all the ends as fixed, and now we will push the structure in rightward direction in the direction of sway and give a displacement delta, right? So assume all end as fixed, so these value will be 6ci delta divide 6ci 6ci 6ci, but thereafter we will have to make a correction. This 6 means this 6 and it's half 3, so we can directly write down, if far end is hinge and this is fixed, so this is 0 and this will be 3, and this is 0 and this will be 3, so we can directly write down. So now we can calculate the fixed end moment due to sway. We can calculate fixed end moment due to sway. Now what will be they? They are MAB0, M bar AB0, M bar BA is 3EI delta divided by 7.5 square, and it is anti-clock means minus. Since sway is clock, so sway moment will be anti-clock. MBC, B2C and C2P will be 0 because there is no relative sway between B2C, right? And CD, C2D is minus because it is anti-clock minus, and D to C is 0, right? Now we can make a ratio. If we make ratio will be like this, divide by something, you will see that ratio will be 0 is to it will be like okay, this is minus 0.44, this is 0, this is 0, minus 1 is to 0, right? Remember, you will not remove this minus sign, however you can remove this minus sign also, but you will not remove because it is telling you the direction, right? Otherwise your result will be opposite, okay? So let MCD, now you can assume any value, let us take 10, 20, 15, whatever you want. So we are taking let us assume any value, this value equal to 25. If this is 25, this value will be 11, or you can you could assume 100, so this would be minus 100, this will be 44. Okay, you can assume any value. So now our moments are these are the assumed moment, which are incorrect moment. Now distribute these moments like the same, distribution factors are same, values are 0, minus 11, 0, 0, minus 25. Distribute and get final answer. This is the final answer. These are the incorrect sway moments. Incorrect sway moment. But we have to calculate corrected sway moments and add these in the in the non-sway moments, right? So in order to calculate the corrected sway moment, we have to multiply the correction factor, and the correction factor is S upon S dash. S is known but S dash is known. How to calculate S dash? S dash will be calculated in the similar manner. Since end moments are known, so this is the member, so this is minus means anti-clock, here 0, this is again minus anti-clock, this is 0. You can take HAHD in any direction. If it will be incorrect, answer will be negative. So I think I should take HAHD in this direction. So now a reaction will be like, one will be like this, other will be like this, one will be like this, one will be like this, one will be like this, right? So we will take bending summation of moment about B equal to 0, so HA will be this, and summation of moment about C equal to 0, summation of moment at C equal to 0, so you will calculate HD. HD will be this. So HA and HD both are positive, means direction assumed is correct. So these will be HAHD. Since no load is acting and these two forces are there in this direction, means one force should be in this direction, that is the S dash, right? That is the sway force due to this delta. That sway force, this is due to this assumed delta. Now this is S dash, so S dash will be, write down the equilibrium, this direction equal to this, S dash equal to this plus this is S dash. Now calculate actual sway moment will be sway moment in corrected sway moment into correction factor, means S upon S dash. Sway moment into correction factor means we will multiply 6.818 in these all moment. Whatever will be the value, we will add these in the non sway moments, which we have already calculated, right? So these were non sway moments. These were the non sway moments. So we write these are non sway moments. These were incorrected sway moments. Now we will apply correction factor, that is 6.8 this. So we will get corrected sway moment. Now we will add this column. This is column 1 and column 2. We will add this plus this, because these are incorrect, and we get the final these moments, right? These are the final moments. So our answer will be this, like this. This is 0. Plus means clock, minus means anti-clock, plus means clock, minus means anti-clock. This is 0. Now we can easily draw BMD as we have drawn in the earlier cases. I also draw deflected shape, right? So this was the case. But in the examination, generally question is asked in which you need not to calculate the non-sway analysis. Means he gives the force on the joint itself. For example, let us see the question of exam. This is the question of exam. I am taking the exam question. This question, most important question of sway analysis. So first method is moment moment distribution method. So look, first aim is, what will you do? This will sway rightward. You will stand here, right, and push it in this direction. You will say this force equal to this, means sway force will be 100 itself, means HA and HD will be 0. You can also imagine like this, if when I will do non-sway analysis, means this span, no loading here, means fixed end moments will be 0, means final end moments will be 0, hence HA and HD will be 0. So whatever is this sway, horizontal load is acting on the joint, same will be the sway force S. So we need not to do the sway analysis. We will do only non-sway analysis. We need not to do the non-sway analysis. We will do only sway analysis. How we will do? Let us see. For example, this is the moment distribution method. Okay, this is moment distribution method. So first of all, in this question we will calculate this and fix, this fix, this fix. Loading is here, loading is on the joint, not in the span. So the end moment will be 0. These all will be 0. These all will be 0. Now when we will distribute, final answer will be 0. Final answer will be 0. Now we will write like this. This will be end, right? This is 100. Okay, this will be 100. This is or you can say, if you cut here like this, you cut here, right, except 100. So you will say that this is 0, this is also 0, this may be any load, this may be any reaction. This is HA, this is 0, so HA will be 0. You can see like this. Take a fresh page. Always remember this thing. This is the load 100 kilonewton. You calculated these moments. These all are 0. All are 0 means you will distribute like this. Zero, 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 zero. No distribution means final answer will be 0, 0. Right? Means MAB equal to 0, MBA equal to 0. All are 0. Now you will cut from here, and you can say that this is HA. Let us suppose this is HD, right? And you have restrained it here. So our answer will be 100 plus 100 equal to HA plus HD and plus R. We can calculate R from here because HA and HD will be known. How HA and HD will be known? Since moments are known, so we can say that cut it here. Let us, this is HA, this will vertical reaction, right? And let us suppose you can say this in this direction, this is 100, right? And see how you can say this. Let us suppose I am cutting from here, so don't take 100. So you will see this is some value 0. This is also 0, right? So this is also 0, this is also 0. We will not consider 100 here because we are cutting from here. 100 will be considered in overall equilibrium. 100 will be considered in overall in this equilibrium. Now we are, and it is a joint, so we are cutting here and here, right? So this is 0, this is 0. These all are some values. So you will take, this is B, summation MB equal to 0 means 0, 0 HA means 4 HA equal to, or 4 HA equal to 0 means HA equal to 0. Similarly here summation MC equal to 0, this is 0, this is 0, this is HD, this value may be some. Summation MC equal to 0 means HD into 4 equal to 0, so HD will be 0, and if HD and HA equal to 0, R will be 100, so sway force will be 100. So you will always remember whenever will be the question, means if question will be like this, look here, this is the question, and he applied 10 kilonewton here. Analyze the frame. You will say that a sway force, you will restrain it here, and you will say that this is reaction, R will be 10, so sway force will be 10 itself. No need to do the non-sway moments will be 0. So always remember this thing. If a load is applied only on the joints, so you will do like this. For example, this is the question. In this question also you can say that you will put like this. This is R will be 100 because loading is not span, so fixed end moment will be 0, final end moment will also be 0, so S will be 100. So if load is applied only on the joint and there is no loading in the span, so end moments will be 0 for non-sway case, and sway force will be equal to the loading applied on the joints, right? So we can proceed our analysis. So we can say that after this knowledge we can say that sway force will be 100 kilonewton and it will be in right direction. Now what will we do? We will do the sway analysis, means assuming all the ends as fixed, right? This beam, right? So both are fixed and 6ci delta divided by it is clock, so it will be anti-clock, 6ci delta, 6ci delta. Since it is hinge, it will be remain fixed, so answer will be 3ei delta divided by L square. Now write down their ratio. All are anti-clock means all are minus, so value will be minus 6ci minus 0 0 itna itna, right? So divide by this, so it will minus 1, it will be r, this is also 4 square, so it will be 3 by 6 means 0.5, right? So this is this one. Let us take any moment value 10, right? So our values will be minus 10, 0 0 minus 5 0. Now we will calculate distribution factors as earlier, as we have calculated in earlier cases. Now using these distribution factors we will distribute the moment. See how we will write the values. The values are given, these distribution factor are this. We will distribute in this manner and calculate the final end moment. Now after calculating this, there is no need to make you understand here. This is general procedure which I have already discussed, right? So now what you have to do, now you will write down the equilibrium. There is the same procedure, just same procedure. You will write the equilibrium, right? One vertical reaction will be there, one horizontal. Here also one this reaction, one this reaction. But we will take, this is B, this is A. We will take summation MB equal to 0. Hence moment of this and this will be 0 and also this will be 0. So we will write that these are clockwise and this also clockwise. So HA will be minus, right? Now HD. We will assume any arbitrary direction. This is 4 meter. HD into 4 plus this value equal to 0 means HD equal to minus 0.96. So we will show here HA and HD in opposite direction. This is 3.27. This is 3.27, right? Like this, and this is 0.96. So now again write down equilibrium. This equal to this means S dash will be this. Correction factor will be S upon S dash, means final answer is this, multiply this correction factor value in non-sway moment. So final sway moment will be this, multiply this, right? And non-sway moments are 0, so final end moments will be this are only. So answer is this. These are the value. Corrected sway moments are correction factor into incorrected sway moment. These are, and since non-sway moments are 0, hence final answer will be this itself. So these are the values. These are value. Now we will plot. This is minus means anti, plus means minus anti, plus clock, and minus anti, right? Now draw BMD. Take outer face as reference face. This is reference, this is reference. Now we can draw like this. Okay, so see, this is arrow is inside means minus will be plotted on reference face. So we can look, we will plot minus on reference face. We should plot in this side, but it is our convention, we can plot this side also, but we will tell him that minus means tension on reference face, and reference face is outer face. Okay, so means its bending will be like this. Minus means tension on reference face, plus means compression on reference face, plus means compression on reference face, minus means tension, and minus means tension. Outer is reference face, so it will sway in this direction. So its deflected shape will be, here will be like this, and here will be like this. Now here will be like this, again this, and again this. This will remain 90, and this will also remain 90. Okay, so this was the question of sway. Now next.